Now we're going to go through the last chapter. It's on linear regression. You guys might like this chapter because it's fairly easy in my opinion. We're going to be doing more calculator work, and we're going to be dealing with equations that you may be familiar with from previous math classes. So the type of data that we're going to be talking about in this chapter is called bivariate data. Bivariate data. That just means there are two variables. Now, in real-world problems, there are usually more than two variables, but we're just going to talk about two variables here. Now, the question is, are the two variables we are talking about related in any way? So, something that we measure is something like the height of someone versus their weight. Their height versus their weight. As you get taller, does your weight go up? Or as you get heavier or lose some weight, does your height go down? Are they related in any way as you are growing? Of course, if you're an adult, your height doesn't change. The only thing that really changes is your weight. But as you're growing, okay, from a kid to an adult, are your heights and weights correlated to one another? Okay? That's the type of things we're going to be asking in this chapter. So now, if you look at the word linear correlation, linear regression, you look here, you see the word line, we're going to be dealing with lines here. So let me write the equation of a line. You guys have probably seen this before. Y is equal to mx plus b, where m here is the slope, and the slope tells you how much you are going up or down as you go over. Here's the formula for the slope, y2 minus y1 divided by x2 minus x1, where y1 and y2 are any 2 points on the line. And over here, this b is the y-intercept. So that tells you, down there's b, that's where the graph is going to start. And then if you have a slope, whatever your slope is, and you draw your equation in a line. So you go up however many over however many. Now, when we're talking about an equation of a line, we've got independent and dependent variables. So this one is the dependent variable, and this one is the independent variable. Now, let's go ahead and talk about exactly what that means. So the dependent variable, if you think about the word dependent, what does it mean to depend on something? It depends on another variable. We have to know this variable in order to figure out this variable. Okay? This is called the independent variable because this is the one we're going to specify. Normally, we want to know what y is if we know x. So we plug in our x to figure out our y. So let's look at an example real quick. I pulled this example out of the book. If you read that person's name, I'm gonna try to say it. Let's see. Oh, that's really easy. Svetlana. I just quickly looked at it. Svetlana's tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour of tutoring. A linear equation that expresses the total amount of money as Svetlana earns for each section she tutors is y is equal to 25 plus 15x. What is the independent and dependent variables? What is the y-intercept? And what is the slope? Interpret these using complete sentences. Okay, so let's go ahead and identify our independent and dependent variable. The one that's solved for, this is going to be the dependent. Right there is the independent. This variable depends on this one. Now, don't just think it's always the dependent y and the independent x. That does not necessarily have to be the case. Okay? We could have said D for dollars, and instead of x, we could have used H for hours in this problem. Okay, so don't automatically think you just see an x, it's automatically independent variable. You automatically see y, it's automatically dependent variable. Okay, it depends on the scenario and where the values are. Let's see, what is the y-intercept? Well, the y-intercept is right there. It's the one without the x. What is the slope? Let's see, I gotta grab a different marker. There's the slope. Alright, so it wants us to interpret each piece interpret these using complete sentences. Alright, I'm not gonna write out the complete sentences on here. I just don't have enough room. So, the dependent variable, we could just read it. It says that's the total amount of money she earns for each session. Okay? This is the total amount of money she's going to earn in each session. This y-intercept is a one-time charge every time you go to tutor. Okay? So, you go to tutor and she charges you $25 plus $15 an hour. So meaning if you just go up to her and ask her one question, she's going to charge you $25 right off the bat. Even if that question takes like 5 minutes, she's going to charge you $25. We haven't gotten an hour yet, so technically we're at 0. So that's what that's saying. She's automatically going to charge you $25 no matter what. It's her one-time fee. The slope here is how much money she's going to earn per hour for every hour she's tutoring someone. So if someone comes and needs to be tutored for 4 hours, 15 times 4, she would get $60 from tutoring 4 hours plus her 25. So that's all it's asking. Identify what they are, what they mean. Let's talk about how to actually write the equation of a line. Last example in this section. These sections are fairly quick. It says Aaron's word processing service does word processing. The rate for services is $30 or $32 per hour. So $32 per hour. Plus $31.50 one-time charge. So $31.50 one-time charge. The total cost to a customer depends on the number of hours it takes to complete the job. Find the equation that expresses the total cost in terms of the number of hours required to complete the job. Okay? So what it wants us to do is find the cost. We could label it C in terms of hours. That's what it's asking. Find the cost, hours, we'll call it H. Find the total cost in terms of the number of hours required to complete the job. So, what this means is C in terms of hours means you should have C equals, and hours should be over here. So it's going to be some slope times hours plus some y-intercept. So this is C is in terms of hours, H. It means you have C solved for. If I were to write it like this, this means Y is in terms of X's. That doesn't mean that it has to be linear. We could put other things here. Y is still in terms of x's. That saying just means that we have a specific variable solved for, y, and it's equal to terms of x's. Everywhere you see here as a term of an x or it's a constant. That's all that means. So now just pretty much picking off the information and putting them where they go. So if you look, $32 per hour, that's a rate. Slope is a rate. It's always some quantity divided by some quantity. Y2 minus y1 divided by x2 minus x1. So the cost is going to be equal to, well, 32 times however many hours plus this one-time charge of $31.50.